Hi, my name is Ed Sperr, and I'm the Clinical Information Librarian at the Augusta University, University of Georgia Medical Partnership here in Athens, Georgia. I'd like to spend a few minutes to discuss how visualization techniques can be used to display and contextualize the results in our collections. I'm also going to do a little bit of a demonstration of an application I developed called Collection View. Now here's an example of a very large, fairly heterogeneous database, the main interface for searching the Library of Congress. Now, if we were to do a search for a random term, let's say in this case, pandemic, we see that what we get back is this very long list of results. So long they have to paginate it. It's over 7,000 results. And really, this ordered list is the main access point we have to all of these results in this database. Now, the Library of Congress is certainly not unique in terms of having this kind of interface. Indeed, the ordered list is probably the most common interface technique used for all of our systems, from bibliographic databases to our catalogs. Even the general purpose search engines that our users are most familiar with all present their results primarily as an ordered list. Now let's do some things pretty well. First off, because they're so ubiquitous, most of our users already understand how they work. Also, an ordered list does provide good access to those items that happen to be visible on the screen at a given time. When you see a hot link, you can click straight through. However, lists do have some disadvantages as well. The primary one is they're only ordered along one axis. Whether we're talking about data publication or about presumed relevance to the searcher, the only real information about an item that we have is its position on that list. Perhaps most importantly, lists don't do very much in terms of showing the context for a given search, or how the different parts of a complex search relate to one another. Now, the reason we have to be concerned with what lists do well and what they don't do well is because our users approach our systems with very different tasks in mind. Now, sometimes users approach with fairly simple searches. They're looking for a known item, or they're looking for 4 or 5 good references for a class. But sometimes they have broader ideas in mind, like trying to browse an entire collection to see if it's worth looking at more closely, or doing very rigorous, complicated searching that you might do for a systematic review. In these cases, we really have to be cognizant of what our systems do well and what they don't. Now, many times when we think about complex searching, we think about it being an iterative process. And certainly that's the way we often teach it in bibliographic instruction classes. We approach it with the idea that a user is very unlikely to light upon the perfect search the very first time out. Instead, you're going to have to look at what you get back, figure out if it's not enough stuff, figure out if it's too much stuff, figure out if it's the wrong stuff altogether. You're going to have to change your search strategy. And indeed, the expectation is that a user might have to change their search strategy 2 or 3 or 4 more times until they get it dialed in the way they want it. Now, the limitations of lists really become an issue when we start using this method. Because if all we have to go on in terms of how well our search is working is the total number of search results, or that tiny window of results that happen to be in the screen at a given time, that might not be enough information. Now, if we're to take a closer look at those results in the Library of Congress, we do see one potentially pretty informative thing. We do have some facets on the left-hand side. And again, these kinds of information scent marking can be seen in many different systems. And it gives us a little bit of context in that we can see how many items fall into each of these individual categories, topmost being the formats, the original formats of the items. Now, this is pretty helpful. It does give us information about things along more than one axis. And it is sometimes easy to see which number is bigger and smaller. But I would argue that when we see lots of these numbers stacked up next to each other, it becomes a perceptual challenge. It's kind of hard to see which number is exactly bigger or smaller than another one and how those numbers relate. Now, if we take that very same information and repurpose it as a visualization, in this case a stacked bar graph, we have a better sense of how those different formats compare to one another. So again, just like with that list of numbers on the left-hand side, we can easily see that photos, prints, and drawings make up the largest portion of the total results set. But we can also see that books and web pages are pretty close behind, and that there's a very big drop between legislation and the other format types. Now, it's important to note that all of the information from that original web page, whether the long list or the numbers from the facets themselves, are also available from this API at the Library of Congress maintained by LC Labs. And this is important because since this data is available through this API, we can talk to it programmatically and construct visualizations to our heart's content. And indeed, we're going to spend a little bit of time looking at an application that I put together called Collection View. You can find it at this URL that does exactly that. Now, before I demonstrate the application, I do want to talk a little bit more about visualizations. Now, certainly, I think it's arguable that one pro in terms of using visualizations is they do a much better job of summarizing complex data than lists do. We have a snapshot view instead of having to troll through an entire list. And also, if we could find a way to do an interactive visualization, we could theoretically show how changes in search strategy affect what's going on in real time. Of course, the big disadvantage to a visualization is that it's not as simple as a list. Many times we might have to explain to a user what's going on. Now, when using visualization techniques to describe and contextualize search results, we're taking advantage of two big properties of items in these kinds of databases. First off, the notion that items have discrete attributes. So we can talk about the format of an item, or the date of an item, or maybe the subjects that an item is indexed under. And all of these things are groupable, so we can comprise individual portions of a search and graph those out. But also searches themselves make sets. So we can compare different result sizes from different search results. We can also talk about relationships between one group of results and another. So if we take a look at Collection View, we do see that we have that initial visualization of the different formats available for a given search. But we can also think about taking a complicated search and breaking it down into constituent parts and taking a look at how those individual parts relate to one another. So we could also think about the two eternal verities of death and taxes. And we'll try to see if there's some sort of relationship between those individual pieces of this broader search. And sure enough, if we go down and we wait just a minute for this to load, we can see that indeed, unsurprisingly, since this database is something that has a lot of legislation in it, there is a good bit of stuff about taxation. And there's also a fairly good bit of stuff about death as well. But what I personally find kind of surprising is this pretty large overlap between these two different sets. And again, this is the kind of insight that's available when we use this sort of visualization technique. Now, besides graphing the relationship between individual sets and doing visualizations of the raw numbers of search results in different formats, it's also worthwhile thinking about the baseline of the collection itself. Here's a quote from Edward Tufte, because of course it's a lecture about visualization and where would we be without Edward Tufte. But this really brings home the idea that we have to think about baselines when we're thinking about comparisons, because comparisons are oftentimes where we can sort of glean information from these visualizations. So if you think back to that slide before, when we took a look at that pretty large section under web pages for our pandemic search, well, we know that there was a lot of items for that search, but what that doesn't tell us is whether or not, that is something that is unusual in any way, shape, or form. Maybe there's always a lot of web pages in all the searches. Only by comparing to the collection as a whole can we actually see whether or not this is the case. So if we're to go back to our pandemic search, we're to scroll down just a little bit to our proportional graphs, we can see that sure enough, in proportional terms compared to the collection as a whole, that is an unusual number of web pages. It's also a fairly unusual number, an unusual proportion of photos, prints, and drawings. Legislation, also kind of unsurprisingly, that's a topic that people are pretty concerned with nowadays, and a relatively low number of books coming back from that search. By the same token, we can take a look at our year readout as well, because that's another one of those facets that's generally available for most searches, and we can see by century, the current century comes out well ahead of any other century in the database in terms of results for the term pandemic. So something we don't see so often with our online catalogs, but is actually pretty common in big bibliographic databases like PubMed, is this notion of tracking search strategies. Again, to facilitate that notion of iterated searching, trying to dial in the perfect search strategy. So certainly over the past several months, many of us have paid more attention to bird life than maybe we had before. So we could take a look at the catalog and say, well, I want to look at things about jays and larks, and I'll go ahead and throw in starlings as well. So we have three individual searches. And just as in our earlier example, where we're comparing parts of our complex search, we can actually compare these individual searches as well. So I'll go ahead and select all three of these and hit compare. And if I scroll down, I notice a couple of different things. First off, poor starlings. Apparently nobody cares about starlings, but also there seems to be a lot more stuff about jays than the other two birds. And indeed, that stuff seems to be a lot more heterogeneous in terms of formats. And again, if we look at our Venn diagram, we can see that that circle for jays is a bit larger than all of the other circles as well. And indeed, if we were to take a look at a search of jays in the Library of Congress system, we would see that, oddly enough, there are a lot of people named Jay, a lot of legislation that comes up when we use the search term Jay. So we have to regroup and change our search accordingly. So if we're to go back and clean up our search a little bit by doing jays and bird and larks and bird, we might be able to see whether or not this makes sense in terms of really getting us to those bird items as opposed to everything else there might be. So I'll try compare. Again, starlings kind of left out in the cold, but it does look like those searches are a little more congruent the way I would expect them to be instead of jays sitting out there by themselves. So just as it can be helpful in terms of visualizing raw numbers of items for each format, as well as the relationships between different sets, sometimes those proportional graphs can really help us check our work as well. So for example, I'm going to do a search for operating system. I do that search, I get back these formats. You know, see a lot of newspapers sometimes with some of these searches, so maybe that doesn't surprise me so much. Maybe expect to see a little more in the way of books. So yes, newspapers up, books down. But then if I go down to my century proportional graph, see something that's kind of troubling. I'm not really sure if there's operating system on the Watt steam engine, but it's just really not what I would expect to see in terms of a higher proportion of things being from the 1800s through the 1899. So let's try to tighten that search up a little bit and see if we can get it to make sense. So if instead are to do that same search string in quotation marks, make it a little bit more specific, indeed, it gets to be a smaller search, and more importantly, those centuries make a lot more sense. As I noted before, Collection View gets its data from that Library of Congress API maintained and developed by LC Labs. It's basically a browser-based application, so written in JavaScript with a little bit of jQuery and Bootstrap thrown in. And in terms of visualization, it uses Google Charts as well as Ben Frederickson's excellent overlay of D3JS, then.js. This is a live application. Currently lives at espr.github.io/collection-view. Feel free to bang on it. Please feel free to let me have any feedback, any enhancement requests, any critiques. Be gentle, it's a work in progress. If you want to see the source for this application, you can find it on my GitHub page, github.com/espr/collection-view. So as I said before, this iteration of Collection View enables us to explore the collections of the Library of Congress. But of course, these same techniques could be used for other databases as well. And indeed, if you were to navigate over to searchworkbench.info, you would see similar work that I've been doing visualizing results from PubMed. So that's the end of my presentation. Here at the virtual meeting, I'll be in the Whova platform to take questions. But if you think of something later, or if you happen to be watching this presentation in a different venue other than during Code for Lib 2021, please don't hesitate to send me an email at espur@uga.edu. Thank you for your time.